Hello everyone, my name is Arpit Misra, and as I told you yesterday that I am going to start an YouTube channel where I gonna cover uh, in which there is full concept video series, PYQ series and practices and many more things. So today I start with full concept video series in which today I will gonna start with physics and its first chapter, that is kinematics 1D. So let's start. In kinematics, we all know that it is the study of motion without knowing its cause. And when we study the motion with knowing its cause, is called dynamics. So in our in this video, we will cover up the full uh, concepts of kinematics 1D. So let's start. We start with speed and velocity. As we all know, speed is equal to distance upon time, in which we all know distance is ab, how much it is traveled, how much is this measurement is called distance. And when we with respect to we measure it with respect to time, then it is called speed. When we speed and it's we all know its unit is equal to meter per second. And speed is can be zero and can't be never be negative. It can't be negative. It can't be negative. And second thing is velocity. Velocity is equal to displacement upon time. We all know what is displacement. Final point my final point minus initial point is called displacement. And displacement upon time is velocity, and unit of velocity is meter per second, same as speed. And velocity can be zero, positive, and also can be negative, because when displacement can here it is a vector quantity, that's why it can be negative also. Third thing is average speed. Average speed is basically total distance traveled upon total time taken, in which we when we have so much of distances, just for a to b 5 meter per second, and for c to d b to c 6 meter per second. So we will calculate it all and measure the seconds. Then it will be 65 plus 11. So it is called meter per second is average speed. Average speed what of total distance traveled upon total time taken. Now come to average velocity. Average velocity is equal to total displacement upon total time, and this displacement is equal to v of u final point minus initial point upon total time. It is called average velocity. We all know it. Uh, Instantaneous speed. Fourth, instantaneous speed is the magnitude of velocity at that time. It is when we differentiate for any particular instant. And then it's what its magnitude would be. Here we, by these lines, we represent the magnitude, and this will named instantaneous speed. And now come to instantaneous velocity. Velocity at spontaneous velocity, when which where we differentiate the position with that time, with that particular time, and we got our instantaneous velocity. Oh. Now come to acceleration. We all know rate of change of velocity with respect to time is called acceleration, and its unit is meter per second square, and it's also an vector quantity. And it is the formula of acceleration v2 minus v1, change in velocity upon change in time, that is called acceleration. Now come to average acceleration. It is same as usual, like change in velocity upon total time taken is called average acceleration. When we have too much of acceleration, then we find it by average acceleration. Now come to instantaneous acceleration. Acceleration at a particular instant of time is called instantaneous acceleration. Here we differentiate the velocity with that particular time, and we got our instantaneous acceleration. Now let's see few important points. When a particle moves with non-uniform speed, then acceleration of the particle must be non. It's very common particles move with non-uniform speed, then acceleration of the particle must be non-zero. It is the points you have to note it down. And second thing is the direction of average acceleration vector is the direction of change in velocity. The direction when we got by average acceleration is basically velocity. Acceleration which opposes the motion of body is called retardation. Retardation is not decreasing acceleration, it is that acceleration which opposes the motion of body. Sign of velocity. Sign of velocity represent the direction of motion, but sign of acceleration indicates the direction of acceleration. Okay, here you got like what we got of velocity, it represents the direction of motion. That direction motion it is doing. Acceleration which opposes the motion of body is called retardation. As we all know, what is decreasing acceleration? That is not an retardation. It is an acceleration which opposes the motion of body. Now come to fifth point. Sign of velocity can be positive or negative, represent the direction of motion, but sign of acceleration indicates the direction of acceleration. Here we know that sign of velocity represent the direction of motion, but sign of acceleration indicates the direction of acceleration. You can all understand it by just reading. Okay, now comes to 6 point. If velocity and acceleration both are having same sign, the magnitude of velocity speed is increasing, and if both have opposite signs, the magnitude of velocity is decreasing. If velocity and acceleration both are having same sign, if v and acceleration have same, both have same sign, then a magnitude of velocity magnitude of velocity will increase. And uh, if if they have opposite signs, then its magnitude will be, it will be increasing speed. And if it is opposite signs, then it will decreasing speed. It will have decreasing speed. Okay, now comes to differentiation and integration. When we need to convert position into velocity, then we differentiate, and it gives instantaneous velocity. And when we differentiate velocity into acceleration, when we need to find instantaneous acceleration, then we differentiate velocity and we got instantaneous acceleration. And when we reverse the process, we have to find velocity through acceleration, then we differentiate acceleration, and then we got velocity. And when we have to find position by velocity, then we have to integrate velocity, and then we find position. We also just like thing, if we differentiate position, then we got velocity, and if we differentiate velocity, then we got acceleration, so instantaneous acceleration. And when we come from here to here, then we have to be double, it will call double differentiation. when we that would be it also gives its acceleration is equal to v into differentiation of velocity upon differentiation of position. Now comes to equations of motions. V vector is equal to u vector plus a vector into time t, and s vector is equal to u vector into t plus 1 upon 2 a vector into t square. And third is v square minus u square is equal to 2as, and fourth is for finding snth position. Snth is equal to u plus 1 upon 2 into a bracket में 2 and minus 1. Here we all know that v is equal to final velocity, u is equal to initial velocity, and it is acceleration. A is equal to acceleration, t is equal to time, and s is equal to displacement, and s and nth is equal to displacement in the nth second. So now comes to derivation of these equations, how it comes to us. Derivation of equation of motion for one-dimensional motion with a is equal to constant. We all know that equation of motion is only valid when acceleration is constant. So now let's find its derivation, how to it comes to us. Uh, a is equal to dv upon dt. We all know a is differentiation of velocity with respect to time, and then integrating, if we integrating both the sides after finding it, we when we integrating both the sides with having with putting limits t is equal to 0 and velocity is equal to v u here, and t is equal to t and velocity is v here, and then we find that our first equation of motion by upper limit minus lower limit we all know, and when we find our first equation of motion. Now comes to second. We all know that velocity is differentiation of its position, then from this to this ds equal to v dt. When we put a value of v here, when we put the value of v is equal to u plus at here, then we find that ds is equal to u plus at dt, and when we putting the limits t is equal to 0, suppose, and displacement is equal to 0, and t is equal to t and displacement is equal to s, then we find after integrating it, and then we find that our its displacement is equal to ut plus 1 upon 2 at square, and it is the second equation of motion. We already learned that acceleration is equal to v into dv upon ds, and from here to here v into dv is equal to d acceleration into ds, and when we put limits s is equal to 0 and v is equal to u here, and s is equal to s here, and v is equal to v here, and after integrating by v minus u, we all know that, and we find our third derivation. And now come to an important point, that here s represent only displacement, not distance, and here in uniform acceleration we use the equation of motion, and in non-uniform acceleration we use differentiation and integration method for finding values. In kinematics numerical problem, when we have given uniform acceleration, then there we can use kinematics equation and to find our answer of values, and when there is no uniform acceleration, then we use differentiation and integration method for finding their values. And now we come to difference between distance and displacement. As we all know that s in equation of motion is really the displacement and not the distance. So for finding distance we have to use this kinematic equation in some specific manner, and let's take some cases of that manner. I mean, first case is equal to when initial velocity is either 0 or parallel to acceleration, then motion is simply accelerated, and in this case distance is equal to displacement. When initial velocity is equal to 0 or parallel to a, then we have to simply find the value of s displacement, then it is also equal to our distance. And now come to case 2, which is very important. When u is anti-parallel to a, the motion is first retarded and then accelerated in opposite direction, so distance is either greater than or equal to displacement. In this case, when Now come to the case here, u is either 0 or parallel to a, so that's why distance is is equal to displacement. But when u is anti-parallel to a, here a u can distance can be greater than displacement. So in this we have to first find that in which time the velocity is 0, and after finding that time, uh, now if we are given time t is equal to t0, that it is the time when velocity comes 0, and is the total. And if distance and displacement are equal, so d is equal to s is equal to ut plus 1 upon 2 at square. When total time is greater less than or equal to velocity time, when velocity comes 0, then our displacement and distance is equal. And now comes to second point, time total time is less than or equal to t0, then we have to use their u positive initial sign convention and acceleration को now come to third point, where total time is greater than 0. Here distance is greater than displacement, so we have to we add the total two time here, d1 plus d2. Here d1 is equal to distance traveled before coming to rest, and it will be find by magnitude of u square upon 2a. And this you have to note this formula, which is very important. And this t2 will come, this t2 is basically the distance travel in remaining time, and total time minus velocity time to 0, and it will be found by this equation. And you have to note down it, it is very important, 1 upon 2 and magnitude of acceleration into t minus t0 whole square. And when we add u square upon 2a and plus 1 upon 2a, 2 t minus 2 0 and whole square, then we find our distance. And you have to learn this important, this is very important, using in kinematics equations and the numericals, that would be helpful for you and for your answers. So it's all today's video. Now tomorrow will a video come that was kinematics second part for 1D. Thank you so much. Please like, share and subscribe our channel, and share with your friends and relatives. Thank you so much.